right, solve for an angle in right triangles. All right, so this is very similar to the last assignment where we were solving for a side in right triangles. There's one big difference. So first thing you want to do is, once again, acknowledge what we are looking for and what we have. So you can see we are looking for an angle now. Instead, we are usually looking for a side. So that's going to move where our x value is. So that's the first main difference. Oops, that's not what I wanted to do. I want to change my color. There we are. So what we do know is we have this side length and this side length. And as I always ask, identify your hypotenuse, which is here. And we don't care about the hypotenuse, which if you look at the board, that means that we are going to be using tangent. Tangent does not use the hypotenuse. Both sine and cosine do. Tangent does not. So tangent is the function we are using for this question. And remember, our angle measure always goes inside our function. And this time, our angle measure is unknown. So I'm going to use x, or you actually use theta instead. Theta. It's like an x. It's a variable. It's an unknown. If you put x in there, that is fine as well. I just know a lot of times people use theta. So I want you to recognize what that is. It's a Greek letter, just like ABC, just a different language. Now, we want to look at where our 2 and our 5 goes. So our angle is here. Remember, tangent is opposite over adjacent. So our opposite side is our 5. And our adjacent side is our 2. So opposite over adjacent is 5 over 2. Now to solve this, the problem, like we don't have on the sides, is our unknown, our variable, is inside of a tangent. So to get that out by itself, there's a function. It's called the inverse tan. This is on the calculator. I can show you guys all this in person if you need to. So tangent and the -1 is the biggest thing. That's what's going to cancel out the regular tan. And do it on the other side as well. I don't have a lot of space here. I should probably actually move my 5/2 over just to make it a little bit easier. So 5 over 2. And we're going to take the inverse tangent of that side as well. This part right here, oops, down here at the bottom, that is the inverse. Okay, or opposite. Sorry, this software is not the best for drawing S's in. There we go. Opposite. Oh, this is there we go. A little better, not best. But. Okay, now that we are here, let's see what color should I use? I will use yellow. So now this inverse tan and the regular tan go away. Theta is left by itself, equal to the inverse tan of 5 over 2. All right, so I would like you to use my calculator that is provided in my classroom, but for these purposes, I'm going to use the one on here because you guys can see this one. Oh, I got to get rid of. So, all right, this is the answer. I'm going to type this into the calculator. I have to get rid of the drawing to get my calculator out. So inverse tan of 5 over 2. So here's our calculator. Here's the inverse tan button. Yeah, see, it comes out a little bit funky in here than I used to. Equals, I think I got to put a 68.19. It says average to the round, or round to the nearest hundredth. So 19, the number past the 9 is an 8. So that means that my 9 becomes a 10, and my 1 becomes a 2. So 68.2 degrees. All right, question 2. So, like the last problem, identify our unknown. All of these will be a unknown of an angle. What do we have? Well, we have a hypotenuse, so it's not tan. And we also have the opposite. Opposite and hypotenuse means we are using sine of theta, our unknown, equal to, sine says opposite over hypotenuse, so 8 over 9. And we're going to do, I'll do the same thing as last time. Give myself a little more space. 8 over 9. Then we're going to take the inverse sine and inverse sine. So, gone, gone, theta is left over, and that equals inverse sine of 8 over 9. Inverse sine of 8 over 9. So inverse sine, 8 divided by 9, parenthesis, equals 62.733. The second 3 is less than 5, so stay as 62.73. All right, let's do at least one more. Okay, where's my, there it is. All right, so once again, our unknown is an angle. And we once again do have a hypotenuse, so it is not tan. And we have an adjacent at this time, so we're going to be using cosine. So cosine is adjacent over hypotenuse. Oh, whoops, I forgot my theta. Oops, made a mistake. Cosine of theta equals 5 over 9. Give myself some space for my inverse cosine. Now we're going to do the inverse cosine. And inverse cosine. And by design, that's gone, that's gone. We have left over our theta all by itself is equal to what's right there. So inverse cosine of 5 over 9. 5 divided by 9 equals 56.251. The 1 is not 5 or greater, so it is simply 56.25. Now I'll do one more real quick. So here we don't have a hypotenuse, so we know we're using tangent of theta, and our angle is down here, so it is opposite, which is 5, over our adjacent, which would be 7. Inverse tan, inverse tan, and like the last 3, gone, gone, theta by itself, inverse tan of 5 over 7. $35.537. Now the number past the 3 is a 7, which is 5 or greater. So it'd be 35.54. Ta-da!